Okay, this is Math 2, and we're going to do 111, 112, 113, 115, and I should caution you, I'm not doing all of 111 and all of 112, just partially, and then I'll set you up for 113. So on 111, the only one that I wanted to talk about was part E, and it says examine each diagram below, which diagrams are possible. So you need to use what we learned today, which is about longest side is across from the biggest angle, and the smallest side is usually across from the smallest angle. And then you need to remember that triangles, the interior angles of a triangle always add up to 180. And remember that in order to make a triangle with sides, if you have two sides, the other third side is going to either be as big as the other two sides added together, or the other two as small as the other two sides subtracted from each other. So those are the concepts that you're supposed to apply for problems A through D. Okay. Now on problem E, I'm going to work this really quickly just because it's kind of fun. You have 10, 10, or actually 10 feet, 10 centimeters, which by the way, it's not so much that so you need to watch for that, okay? So 10 centimeters is obviously smaller than 10 feet, even though they're both 10. And then this last one up here, we want to figure out what that top angle is. So 180 minus whatever 59 plus 62 is, which is 121. So 180 minus 121 is 59. Okay. So this is going to also be 59 degrees. And so now we have the largest angle, which is 62 degrees, and the two smallest angles, 59 and 59. So you can have two smaller angles. It's fine. But there's a problem, right? 62 degrees is across from 10 centimeters, not 10 feet. So 62 degrees has to be across from the longest side. And that's not true in this picture. So we've got a little bit of a problem. So technically, which are impossible, this is impossible. You will never have this one be 10 centimeters and this one be 10 feet. 62 has to be across from the largest side. 59 has to be across from the smallest side. Okay, that was 111. The next one on 112, the only two, actually B and this one are kind of together. So if you do A, use your intuition, okay? That should help you with part B also. So 8 times negative 8 should give you negative 64, and 8 plus negative 8 should give you 0, okay? And the question is, what times what is going to give you negative 25? And then when you add it up, it should give you 0. So A and B kind of go together. This one, on part C, is really easy. 4 times what's going to give you negative 12, and then just add them up. Okay, I needed to do this one because it's got fractions in it. Nobody ever likes fractions. So 1/2 times negative 1/3. So 1/2 times negative 1/3 should give you negative 1/6. So that should go up here. And then 1/2 plus 1 plus negative 1/3 should give you common denominator of 6, right? Times 3 should give you 3, times 2 should give you negative 2. So 3 plus negative 2 should give you positive 1, 6, and then 6 on the bottom. So this is going to be a sixth. Okay? Alright, so that was 112. And then 113, I'm going to set you up for this. Now these are parallel, so that means if I trace 119, right, I can slide it up, and its corresponding angle will also be 119 over here. All right. Now, now it should help you out a little bit because 119 and 5x plus 11 are both on a line together over here. So that means 119 plus 5x plus 11 should equal 119 plus 5x plus 11 should equal, so this plus that should equal 180 degrees, okay? And you should get a value for x, whatever that is. Alright, but you're not done yet. You still have to find y. And it's the same thing for y. 119 and y, right, are both on a line together. So 119 plus y should equal 180. Okay? And you should get a value for y. So those are those two for 113. 115. We have on graph paper graph ABC with the vertices -3, -4, -1, -6, -5, -8. I don't know why they all have to be in the negatives, but apparently they really wanted it to be in the negatives. What is the length of AB? Okay, so that's the important one. And then B, C, and D translate, reflect, and rotate. So the main one is what is the length of AB? So we're going to talk about that first. There's the 3 points, A, B, and C. Hopefully I graphed them correctly because I think I did. The question is, what is the length of AB? So if you zoom in on this really quickly, the length of AB is not 2. Just because it's going from this corner to this corner, it's going like one corner across and another corner across, it's not 2. You cannot count on a slant. You can only count going up and down, side to side. And since from A to B is not going up and down, side to side, it's going on a slant, you can't do that. Okay, you can't just say 1, 2. What you have to do, mandatory, is create a right triangle with the lengths A and B being the hypotenuse, and go from there. So what I'm going to do is I'm going to create a right triangle using these 2 legs, okay, with the top length up here being 2, right, because I can count on this, going left to right. I can go 1, 2, and then down here being 2 also. Okay, so if I take this 2 and 2, and this is my right angle right here, I have, let's see, 2 and 2. So I'm going to say this is x because technically I'm trying to find the length between A and B. Right? So I have 2 squared plus 2 squared is equal to your x squared because your hypotenuse is what you're trying to find. So 4 plus 4 equals x squared. So you have 8 equals x squared. So then x is going to be the square root of 8, whatever that is. So, I don't know, the square root of 8 is something less than 3 and more than 2, whatever that is. There's 8 and square root. 2.8. Okay. So x is going to be roughly around 2.8. Let's round 2.83. Okay. Or the length from A to B is going to be roughly around, or the actual length from A to B is really the square root of 8. And if you leave it as the square root of 8, I'll be fine with that. As long as you understand. If you don't understand how to find the square root of 8 on your calculator, then that's a different issue. But the square root of 8 is what we're going for. Okay, so that's the length of A to B, and that takes care of part A. So part B says translate it so that x and y, so that the x's go up 5 and the y's go up 1. So if you take your triangle, okay, and I'm going to copy it down real quickly. There's A, B, C. It says the x's go, what? To the right 5, so plus 5, and the y's go up 1. Okay, so the y's go up 1. Okay, so that's that. And then the x's are going to go to the right 5. So we're going to go 1, 2, 3, 4, 5. Okay, so we should end up somewhere over here. Okay, so look at where the numbers are and get those coordinates down. Alright, the next thing it says to do is take your triangle and reflect it across the x-axis to form A prime, B prime, or C double, A prime, A double prime, B double prime, C double prime. What are the coordinates of B double prime? Okay, so this is the x-axis, right? So I'm going to draw a line so I know where I'm going. Okay, and I'm going to take it, I'm going to zoom out because we got to flip this. This is my line of reflection. This is my triangle. So I'm going to take the tracing paper and I'm going to flip it with the line of reflection being in the same spot, right? And so I flipped it, and this is where my coordinates are now. So A is over here, B is up there, or A double prime is here, B double prime is there, and C double prime is Actually, it should be up there. Yeah, that's better. There we go. Okay, so that's part C. And then part D says to rotate 90 degrees. 90 degrees which way? Clockwise. Okay, so we're going to rotate this clockwise. Okay, so I've got my X in, and we're going to go clockwise, one turn, so 190-degree rotation, and that's going to look like this. Okay, so 190-degree rotation, this is where your points end up on. So the question is, what are the coordinates of C triple prime? Okay, all right, so that's all of them. If you have any other questions, you can see me. Have a good day.